Hey, 7th graders, today's lesson is 3.1 Metabolism, and your learning targets for today. I can identify the molecules needed to make energy in the cells of our body. Okay, so you guys are going to really look at where we as human beings and a lot of other living organisms get their energy and what do we need to bring into our body in order to do that. So kind of our last part of this unit in chapter 3 is focusing on metabolism specifically. You know, chapter 1 we looked at where does food go in our body. Chapter 2 we looked at how it moves around with the different body systems. And again, chapter 3 we're really going to look at what happens in the cells that create energy in a process called metabolism. First activity for you guys to do today is open up your OneNote and add key concept number 8 to the key concepts page. So in order to release energy, cells need both glucose and oxygen molecules. Okay? Moving on to your activity 2 warm-up. Remember, you guys can pause this video at any point to complete an activity I just explained and then start playing it again when you guys are ready to move on. So for your warm-up today, you guys are going to revisit Elisa's data here. So this is from the last Amplify lesson we did. Okay, molecules absorbed by cells in the body, glucose, amino acids, and oxygen. You guys can see the numbers for a healthy body. Again, these are what we see in the cells of the body. Versus Elisa's body, this is what we see in the cells of Elisa's body. Okay, so using your draw tool, you're going to first answer this question here. Compared to the cells in a healthy body, Elisa's cells are getting far fewer blank molecules, so either oxygen, glucose, or amino acids. So what is she not getting enough of in her cells? Okay, and then how do you think getting fewer of these molecules to her cells contributed to Elisa's tiredness? So remember, this all started talking about Elisa and how her main symptom was that she was just so exhausted all the time. And we looked at her sleep and we looked at her food, and those patterns were normal. Okay, so we started looking inside of her body to see what was going on. And again, these are kind of the results we came up with. Where is she low, and why is that making her tired? Okay, in your opinion. All right, moving on to activity 3. You have a little poll in class. We're going to discuss this and kind of look at who voted on which. But you're going to use your draw tool and you're going to select one answer. Choose the claim you think is most accurate. Claim 1 says that the cells need glucose to release energy. Claim 2, cells need amino acids to release energy. Remember, we get amino acid from proteins. We get glucose from carbohydrates, which include complex starch and simple sugars. Okay, claim 3, cells need oxygen to release energy. So obviously we get oxygen from the air we breathe. Claim 4, cells need glucose and amino acids to release energy. Claim 5, cells need glucose and oxygen to release energy. Or claim 6, cells need all 3 types of molecules to release energy. So choose the claim that you think is the most accurate. Okay? And again, since you're not in class, we can't really discuss this as I won't be able to share other kids' data with you guys. So I just want you guys to kind of keep this question in the back of your head as we move through this unit or this lesson. All right, activity 4, you're going to do a little hands-on activity, and you guys at home will be more than capable of doing this. So first, before you start, I want you guys to make a little prediction. What could changes to your heart rate and breathing rate tell you about what is going on inside of your body? So think about, you know, if you guys start breathing harder or you start slowing down your heart rate. Okay, either of those options, maybe your guys' heart rate is speeding up or your breathing rate is speeding up or both of them are slowing down. What could that tell you about what's going on inside your body? So if we think of like having your heart beat faster or having to breathe faster or breathing more often, okay, what do you guys think? Why? Why do you think that is? What's going on in your body that causes that to happen? Okay? All right, so here's your little hands-on activity today. You guys will be looking at your breathing rate and your pulse, and if you want, you guys can get someone else at home to help you out with this. Okay, you guys are going to be recording both pieces of data. So again, you're going to look at how many breaths you take in a minute. Sorry, and you're going to look at what your heart rate is by taking your pulse. Okay, so first you guys can observe your breathing rate. Sometimes it's really hard to do this because you start focusing in on how many breaths you're taking, and then that kind of throws you off. What you guys will do is you guys will set a timer for 15 seconds. You're going to try to breathe as normally as possible, and you guys will count how many breaths you take in 15 seconds. Okay, you can do it for a whole minute if you want, but it's easier just to do 15 seconds and then multiply that number by 4, and that'll tell you how many breaths you take in a minute. Okay? You guys can also observe your heart rate. So you guys can either place 2 fingers gently on your neck, just right here. You guys can kind of feel how your trachea is right here. You have this muscle that goes right here. In between those two, you should be able to put 2 fingers in and feel your heart rate. Okay? That's probably easiest to do on yourself, or if you have someone, they can test your wrist. So if you're looking on the outside of your wrist, right in between the tendons on the middle, you guys should be able to find a pulse in there with 2 fingers as well. Here's a little video to give you guys a little bit better instructions on how to take your pulse, so you guys can open that up. Looks like this. It's just me talking more. Fun. And you guys can practice taking your pulse. Again, it's probably easier for you to do your own pulse on your neck. So same thing there. You guys are going to measure your pulse for 15 seconds. And then if you guys multiply that by 4, that will be your guys' heart rate, or how many times your heart beats in a minute. Once you guys have established your baseline and figured out what your resting breathing rate is, how many breaths you're taking in a minute, and how many times your heart is beating in your minute, so your pulse, you will record those on the table on the next slide, and then you guys are going to exercise vigorously for 1 minute. So really go ham, okay? Do it for 1 minute, set a timer, and then you are going to do your pulse for 15 seconds and do your heart rate for 15 seconds. It's okay if you guys have to do this twice, and then after the first minute you do your heart rate, and then after the second minute you do your breathing rate. That's totally fine too. And then you're going to go ahead and again fill out this data right here. So at rest, what's your heart rate and what's your breathing rate? And then after 1 minute of intense exercise, here's your heart rate and your breathing rate. If you guys do not have a calculator, you guys can open this link right here. And in order to find your pulse for a minute and your heart rate for a minute, you can multiply your numbers by 4, assuming you counted over a 15-second time period. Okay? And then we're going to go ahead and test some things out in the sim. So again, pause this if you need to complete the exercise portion of this, and then you guys can move on to the sim portion. Okay? So the whole goal in this simulation is to see what molecules the body needs to make energy. So that really goes back to that poll that we did in activity 3. And how we're going to do this is we're going to deprive the body different molecules. We're going to do one at a time so we know what the effect of depriving the body of that molecule is. So you're going to deprive the body different molecules one at a time and see how long the body can jog without each molecule. So if we need it for energy, essentially if we don't have that molecule coming into our body, we're not going to have very much energy and we won't be able to jog for very long. Okay? All right, so here's how you guys are going to run this sim. You're going to gather evidence to answer this question by running 3 tests in the sim. You will be measuring the length of time a healthy body can jog under 3 conditions: without glucose, without amino acids, and without oxygen. So for each test, you're going to launch the sim. Here's your sim link right here. You can right-click and open that up. You're going to choose healthy body and observe. And then you're going to press the sim and set the activity level to jog. So pause the sim, set it to jog. And then for without oxygen, you're also going to stop the breath. So you kind of have to look at the data table to get a good idea of what you guys are going to be altering on each little test you run. So we'll look at that here in a second. Then you guys will press play. You'll feed the body as directed in the data table for that condition. You guys will go to graph view. And then you guys will wait for the point at which that line for activity level is at jog and then drops to walk. And that's what time you're going to record. Remember that when we talk about time units in this sim, we're not talking about seconds because, realistically, if we're looking at 100 seconds, metabolism takes a lot longer. Digesting food takes a lot longer than 200 seconds, whatever the case is. So that might be more realistically like minutes or even longer than a minute. Okay? Immediately switch to graph view and wait for the activity level to drop from jog to walk. Pause the sim and record the length of time. So let's take a look at our data table. This kind of gives us a little bit more information. I'll show you guys the control test. So the control test is already done for you guys. You guys can see your data already in there. And what we know from that is that when we have fed our body glucose, amino acids, and oxygen, that we can jog for 100 to 132 time units before we have to stop and walk, okay, before our body runs out of energy. Okay, let's do test A together. So in test A, we're going to get rid of and deprive the body of glucose. We will not have any sugars or starches of any kind in our diet. and we're going to see how long our body can jog for. So again, we're going to go to healthy body. We're going to go to observe. We're going to pause it. We're going to set our activity level to jog. And for this one, it tells us breath on, feed 1 fish. So we're going to go ahead and give it only 1 fish to eat, which we know fish is mainly protein and a little bit of fat. Okay, so we're going to go ahead, hit play, feed it our fish. And then we're going to switch to our graph view. We can even speed it up. And if we're looking, our activity level is this little purple line right here. So we're going to pause that when we see that purple line drop. Right now, we're still jogging. Okay, but again, when that purple line drops, it means we ran out of energy. We're not able to jog anymore. Right there. Okay, so you guys can kind of click and drag this blue line and say, all right, how do you do that? Right at about 78 time units. So here you guys would write, all right, 78 time units. Oh, shoot. There we go. 78 time. Why is this not letting me type? There we go. 78 time units. You guys are going to run that a second time, okay? So you guys will go ahead, go back to your live view, reset it, start over, yes. We're observing. You guys will pause it, set your activity level to jog again. You guys will hit play and then feed it 1 fish. And again, go back to your graph view. Watch that purple line. You guys can speed it up. Watch that purple line and figure out when, again, that purple line drops from jog down to walk and record that time it does it. Let's talk about your other tests. So you guys will need to figure out, I'll let you record that, and then you guys can figure out trial 2. For test B, you guys are going to do the exact same thing 2 times, so trial 1 and trial 2, except you guys are just going to feed your body 1 corn. Say last time you fed it 1 fish, this time you're only feeding it starch and no protein. Okay, so feed it 1 corn, and again, tell me how long that little body can run for. And then finally, this one's the fun one. This would be like if your little body was holding its breath. You guys will set up, you're going to feed 1 fish and 1 corn, so we're going to make sure we have glucose and protein available in our diet, but our little human is not going to be breathing. So again, you guys can go ahead, hit reset, start over, observe, and then you're going to pause it. Here is where you guys turn your breath off. You're going to hit stop. We're having 0 breaths per minute. You're going to change your activity level to jog. You're going to hit play. You probably don't even need to speed it up. Watch your graph view and see what happens. Okay, you guys will do that twice and figure out how long this guy can jog for holding his breath. Okay, record that time, and then let's go ahead. Once you guys have that done, we'll move on to activity 6. Activity 6, answer that poll question from before. So you guys can look back at your data. Okay, I'll give you a hint. There's 2 things that we need to make energy. Okay, with that being said, which 2 of these don't let us run for very long? Okay, those are the 2 that we need to make energy. One's pretty obvious, being oxygen. Okay, if we're not breathing, we're not getting energy to our muscles. We can't run for very long. Which other one doesn't allow us to run near as long? Okay, compare the data to your healthy body. Okay, and go ahead and use the draw tool to check your answer. And then finally, explain how the results support your poll selection from the last slide. So you made your poll selection here. So how do the results from this data table help support that? So kind of use some of your data to help explain why you chose the correct claim under your poll. Okay, and then finally, let's move on to our homework activity 7. You guys are back in the sim. So for this one, you guys are going to go healthy body. You're going to choose test. And you're going to feed it 6 corn, so that is a lot of starch, a lot of glucose. Okay, do 2 trials for each activity, rest and jog, and record your results in the data table, and then answer the questions below the data table. Okay, so again, in your sim, you're going to reset. We're going to go to test this time. Okay, again, you're going to feed 6 corn to your little human guy. And you're going to do 2 trials for each activity level, which again, you guys will see in the table on the next slide, and then record your results. So what you guys will be recording is how much glucose is absorbed by the cells, how much oxygen is absorbed by the cells, and then what do you observe? Okay, so at rest, we're gonna basically see what happens for how much glucose is observed and how much oxygen. So you guys would go, all right, we're gonna feed it 6 corns, 2, 3, 4, 5, 6. That's a lot of corn. And for this one, we're gonna go to rest. And then you guys will hit play. Remember that we let this run for 200 time units, so you guys might want to speed it up. And when it is done, it will give you guys this information over here. Because amino acids don't take any part in our energy production in our cells, okay, we're going to talk about them later and why they're important, but they do not help us make energy. Obviously, at this point, you guys learned from the last activity that we absolutely need oxygen. We can't do anything energy-wise without oxygen, and we definitely need glucose as well. So those are going to be our 2 key ingredients that we need to make energy. Okay, with that being said, resting, let's see how much glucose is used up in our cells, and let's see how much oxygen is used up in our cells. So you guys are going to test this twice. Again, I'm almost at 200 time units, so it should be up soon, and I should have some data. Right there. Okay, so my results have concluded. I'm also going to write my observations, which I'm going to let you guys handle. Right here we have 36 glucose. So I would say, all right, glucose molecules absorbed by cells. Oxygen molecules absorbed by cells is right here, 199. And observations, you guys can handle that on your own. And then you guys are going to run a second trial there. Okay, I'm going to merge this so you guys can just do one set of observations for both of those. And same with this one too. Okay, you guys are going to do the exact same test, 2 trials, except you're going to do jog. What I want you guys to really look for is how do those numbers compare between resting and jogging, okay? Would you expect to see higher numbers of glucose used up from the cells if we're resting versus jogging, or lower numbers versus, resting versus jogging? So think about what you guys see in those, make your observations according, and then answer these last 2 questions. What differences do you notice between what happens in the rest activity level and what happens in the jog? So what did you guys notice as far as data goes? Give me some specific examples. And then why do you think these different activity levels produce different results? So why do you think that is? Explain why. Okay? Once you guys have answered those 2 questions, you can go ahead and complete your wrap-up, and then you can hand it in. And I hope you guys had a good little exercise lesson, and I will talk to you soon. Bye.